I'm a LIS user and I'm a Zen Buddhist, which means that I go to a Zen practice center and meditate. When you meditate for long enough and in the right way over time, something will happen called awakening. Awakenings permanently transform your perception of reality in a way that reduces suffering, which is good. Awakenings affect your perception of reality in a few different ways, but one of the simplest to define is called ego death, otherwise known as the Great Death, but I'm just going to call it ego death. For a long time, and by a long time I mean thousands of years, awakening is older than Zen Buddhism. Awakening is older than Buddhism itself. For a long time, it's been a mystery as to why this happens. Why does sitting quietly and focusing on your breath for a long time create a change as significant and permanent as ego death? This has been a mystery for thousands of years, but I think that relatively recently, this one guy, a blogger by the name of Stephen Burns, has figured out the answer. Stephen Burns is a writer on the online forum Less Wrong, and Stephen Burns studies neuroscience. But Less Wrong is more an AI forum, which means that Less Wrong tends to think about cognitive processes in terms of algorithms, largely inspired by AI algorithms, which means that from this community's perspective, cognitive algorithms, the stuff going on in your brain, is usually seen as an optimization process, an error minimizing function. And Stephen Burns believes, and I believe too, his argument was very convincing to me, that the reason for ego is because of two conflicting algorithms going on in the human brain, and that meditation solves a problem that is created by these two conflicting algorithms. All right, let's talk algorithms. There are lots of algorithms in your brain, but for the purpose of this video, two of them are important. The first one is reinforcement learning, and the second one is reality simulation. So if you've taken a, let's say, AP psychology class, you're probably familiar with reinforcement learning. Reinforcement learning is the process by which you eat a candy bar, it tastes good, there is a reward signal in your brain, now you're going to eat more candy bars. Reinforcement learning is the basis for behaviorist conditioning, operant conditioning, that thing. And reinforcement learning also is done in machine learning under the name of reinforcement learning in a similar enough way. That's the reinforcement learning algorithm. But many people, I don't know if this is mainstream scientific consensus yet, but the people who, in my opinion, have the most convincing theories of mind believe that there's another algorithm going on in your brain that is perhaps even more important than reinforcement learning. And this is a predictive algorithm. The basic idea is that your brain is constantly simulating reality. Now, there's a couple different theories of the exact algorithm that's doing this, but fundamentally they all are optimizing a very similar error function. The prediction algorithm in your brain is constantly trying to predict sensory inputs. That is, instead of you look out the window and see a building and then it's rendered in your consciousness, the way this works is you look out the window, your brain expects to see a building, and the expectation is rendered in your consciousness. And then that expectation is compared against the building you actually see, and if you see a building, bam, the algorithm is working properly, and if you don't see a building, then there's an update process that is run on the simulation in your brain. That's the prediction algorithm. And the basic idea behind the prediction algorithm is that if you have an algorithm running in your brain that's constantly trying to predict all of your sensory inputs, that is, what you see, what you hear, what you feel, the algorithm will necessarily create a real-time model of you and your environment. Now, what does this mean to you, a person with consciousness? Well, everything you perceive, like me on this screen, it feels like me on this screen is actual external reality. And while it is true that there is a me on this screen in external reality, the thing that you perceive, what you perceive to be me on the screen, isn't actually me on the screen in external reality. What you perceive to be me on the screen is actually your brain's expectation of me on the screen, which has a one-to-one correspondence with external reality. So that's the prediction algorithm. Okay, so what happens when these interact? Well, when these two algorithms interact, a problem occurs. You see, these aren't operating in two separate parts of the brain. These are both operating on the same ball of neurons. And this is a problem because if you're training a neural network, it doesn't matter if it's artificial or biological. If you're training a neural network on one target, then the neural network can optimize that target. But if you're training a neural network on two separate targets, and we've got two separate algorithms here with two separate optimization targets, that can cause problems. And one of the problems it can cause is that the predictive algorithm is trying to predict the environment. And if you didn't do anything, if you just sat quietly with your eyes closed forever, if you were like a rock or a camera, then predicting the environment would be straightforward. It could just follow physics. But you're not an immobile object like a rock. You take actions on the world. You pick things up, you eat things, you talk. And when you take actions on the world, you're changing what the world is going to do. And the reinforcement learning algorithm in your mind, that reinforcement learning algorithm is constantly training you to do new and interesting things to the world, which is great. That's how your mind's supposed to work. But now we have a problem, because when you're doing new and interesting things to the world, well, that means your own mental processes are causing motor actions, which are causing actions in the world. So the predictive algorithm can't just monitor the external world. The predictive algorithm has to model your own mind. And this is a problem, because generally speaking, there is no good answer to can you predict your own mental processes. That's like, that generates all sorts of problems and contradictions and things that are fundamentally uncomputable. So what Stephen Burns believes happens, and which I believe is a convincing theory, is that some parts of the world are treated as mechanistic. That is, they are treated as predictable, kind of like if I drop this lens cap, it'll fall. But other parts, like your own mind, are treated as vitalistic. That is, they're treated as if they have free will and are fundamentally unpredictable in that sense, even though that's not how physics works. Free will isn't real, but when a mind is dealing with something that's fundamentally unpredictable, such as stuff downstream of its own mental processes, well, what if you just sort of paper over that and call it free will? And that, Stephen Burns believes, is why it feels like you have free will, even though physically speaking, the idea that you might have free will is nonsense. And this doesn't just apply to you, because a lot of how our empathy works is I ask myself, how would I feel if I were you? And if I ask the question, how would I feel if I were you, I just run my own circuits of how I feel and guess that you'd feel somewhere kind of similar. And that's how this problem of vitalism, the problem of free will, spreads. Because if I'm modeling you based on my own model of myself, and my own model of myself is inherently vitalistic, inherently has a free will element in it, well, now it feels like you have free will too. And this applies to anything you can empathize with, including cats and dogs. And that's why it feels like me and you and cats and dogs all have free will, even though physically we know that that's nonsense. So the world is fundamentally broken into mechanistic outside world and containers of free will, like me and you. And the container of free will in your mind that is you, well, that's your ego. So how can meditation solve this problem? How can meditation cause ego death? Well, remember, this problem was originally caused because you and I take actions in the world. And what happens when you're meditating? You're sitting still, you're not moving, you're in a quiet room where nothing's happening, you are to the best of your ability not even thinking. So when you're meditating, there is no need for an ego. And when you're meditating, your ego can just disappear, or you can see through that encapsulation. And when that happens, you can see that there is an accurate model of the world that doesn't include your ego, that doesn't include any self in your brain. And once you see that something isn't real, you can't really unsee it. It's like once you see The Wizard of Oz, or once you see through a magic trick, you can't ever believe in the magic trick again. And remember, the ego was an encapsulation layer. The ego was just sort of papering over something. But once you see under the cover what's actually going on there, even if the cover is replaced, so to speak, you're never going to actually believe that the cover was real. You're always going to know what was inside of it. After enough cycles of this, that is, after enough meditation and good living and so on, I believe that your brain rearranges itself so that there is no need for an ego, or rather, there is no belief in an ego. And that, I believe, is how meditation produces ego death.